Okay, let's continue in our equilateral and isosceles triangles. So number 8, we're given triangle RST. They also tell me in the directions that those two sides are equal, so I would strongly suggest that you put that on a picture. Okay, mark it that they are equal. Then they're telling me that these three angles are going to total, or excuse me, tell me what the three angles are, and find x in the measure of each angle. Well, I see two ways to do that, but we know, let's do the isosceles triangle way. These two angle sides are equal, so the base angles, in this case R and S, are going to be equal to each other. So angle R is going to equal angle S. So R is 9x plus 2, S is 13x minus 18. So that kind of tells me, by going through that process, it just tells me which two angles are going to be equal. I set them equal to each other. I solve. Oops. X equals 5. Once I have that, then again, you're just going to plug into all three of those angles and get your three measurements. I'm just going to put these in here. We know these two need to be the same. They are equal to each other. That leaves 86 for the third angle, angle T. Again, you shouldn't miss any of these because you can go through and these three have to add up to be 180. It's kind of nice. You just have that nice solid fact. Number 9, same idea when you look through here, angle D equals angle E. So mark that. So then their opposite sides, in this case DF and FE, are also going to be equal to each other. So DF and FE are going to be equal to each other. Now if you want, you can actually put all of these onto your picture if that's easier for you to see, and then you'll see that DF and FE are going to be equal to each other. So DF is 7x minus 35. FE or EF is 4x minus 8. Go through and solve here. X equals 9. Then they want the measurement of all three sides, so I'm going to plug those back in. And we get 38. And then these two need to be the same. So when you plug that in, you want to make sure that they do come out to be the same. Okay, our second idea is the equilateral triangle, which if you remember from our definition before, is a triangle with three equal sides. And at the time we kind of even mentioned, like, if it has three equal sides, then it is three equal angles. Okay, and this means if and only if means it works both ways. If you have three sides, then you'll have three angles equal. If you have three angles equal, then you'll have three sides equal. You get one, you get the other. Okay, so in this case, if the three angles are equal, then I know the three sides are going to be equal. All of them are going to be equal to each other, the same measurement. And if all three sides are equal, then I automatically know all three angles are going to be equal. Okay? So let's go down here to number 11. You want me to find angle C and then BC and AC. So I know two angles are 60, and since they all have to be the same, C is going to be 60. I'm sorry, they don't all have to be the same. These two added up and subtracted from 180 gives me 60, so now I know it's 180 degrees. I know it's an equilateral, which means all three angles are the same, and all three sides are the same. Okay, so this angle is 60, this will be 9 feet and 9 feet. Number 12, we want to recognize that all three sides are marked the same, which means all three angles have to be the same. Well, if I have equilateral, they all three have to be the same. All three will always be 60 degrees. It's just a fact. So maybe even you want to go up here to this, and they will all equal 60 degrees. That's on an equilateral triangle only. 13. Again, they're kind of giving me some info up here that equilateral, all three sides are the same, so that means all three angles are 60. Okay, so if I want to find the sides, doesn't matter which two I choose, because they're all equal to each other. So I'm going to go with the 14y minus 59. This side is going to equal this side and this one, but I'm just going to use the 9y plus 1. When I go through and multiply solve that equation, I get y equals 12. Okay, so I'm done with that piece. And if you wanted to double check, you could substitute y in for each of those three sides. You should get the same result. As far as the angle goes, I'm only given this one angle, angle R, but we know from our previous problem up here that if it's all three sides are the same, all three angles are going to be 60. So this 7x minus 3 has to equal 60. And there's my value of x. So there are the notes dealing with isosceles and equilateral triangles.